All right, so this is going to be a pretty short video on approximating solutions graphically, but I got a little curious after the last video. And so I went off to the side and said, what is this x-intercept actually? Okay, well, the x-intercept is when y equals 0, and we can just solve. Now, you don't necessarily have the tools to solve logarithmic equations yet. We haven't gotten to that yet. That's 6.5, I believe, or no, it's 6.6. But we subtract 4 from both sides, and now we have something in logarithmic form. We can transfer it to exponential form, and then we just solve this linear equation. And yeah, the actual x-intercept was negative 3.999975. Very close to negative 4, but not actually negative 4, because negative 4 is not in the domain. Let's approximate solutions graphically. Okay. So let's look at example 5. Approximate by graphing. Part A. Common log of 2x minus 3 plus 2 equals negative log of 2x minus 3 plus 5. This is a 6.6 problem, solving a logarithmic equation. We're going to be able to do this by hand pretty easily. This is a pretty simple problem. It looks awful, but a pretty simple 6.6 problem. But we're not to 6.6 yet. So to approximate this by graphing, let's just graph one side of the equation. That's a logarithm that's been shifted right 3, horizontally compressed by 1/2, and shifted up 2. We're going to see when that logarithm equals the one on the right, which has been flipped upside down, reflected across the x-axis, shifted right 3, horizontally compressed by 2, and up 5. All right? In that order. Let's see when those equal each other. We could graph these by hand too, and that'd be kind of interesting, but don't have to. So log of 2x minus 3 plus 2. And the question is, when does that equal the negative log of 2x minus 3 plus 5? And you might say, Jason, these functions don't exist. Well, remember what we're looking at. We zoomed in really far on a negative 3.5. So hit that wrench icon on the right. It's a little off the frame in the preview, but in your Desmos, you should see a wrench icon that's right here. Let's just reset this to like normal numbers. Negative 5 to 5. Negative 5 to 5. Oh, okay, so it's over here. Where do these intersect? They don't intersect, they don't intersect, they don't intersect, they don't intersect, and oh! Right about there. Right about 17.311. That's where they cross. So our estimate, x is going to be about 17.311. There we go. And now, after I finish recording this video, I'm probably going to go off to the side and solve it exactly because I'm curious. Part B. Let's do another one. 2 natural log of 5x plus 1 equals 1/2 the natural log of negative 5x plus 1. Again, these are just the same function, just with different transformations. Remember, this negative here is reflection, a horizontal change because it's on the inside of the function, a reflection about the y-axis. All right, so if we do these ones, what are we going to get? First one, it's going to be 2 natural log of 5x plus 1. And the second one is going to be 1/2 natural log of negative 5x. Plus 1. And we want to know when these cross. Maybe cross somewhere around here. Which one of these is it? This one. At about negative 0.0184. And that's the whole video. But if you're upset and say, man, I'm paying for a college course and Jason only has a 5-minute video for me, don't worry. I have some bonus content. Bonus content for this math video. So in all seriousness, the video's over. Turn off the video, go do your homework problems. But if you want some bonus content, there's a cat, and this is what this cat does. My poor chair. Be kind of cute though. Can have some more bonus content. A little sneak peek, a little sneak preview of what's to come. What if you wanted to solve this exactly? How would you do it? Well, this is 6.6, solving logarithmic equations. We're going to get all the logarithms on one side and all the numbers on the other side. So if we add this logarithm from the right to the left, well, now we have two of them. We're going to have 2 logs of 2x minus 3. And if we subtract 2 from both sides, then that 2 goes away and it combines with this 5, and positive 3. We want to get this in log form, so let's divide both sides by 2. And now we have an equation in logarithmic form. The logarithm of something equals something else. Well, this is log base 10. Convert it to exponential form. 10 to the 3 halves equals 2x minus 3. Now this is just a linear equation. Add 3 to both sides. Notice that we can't really simplify this without approximating. This is the square root of 1,000. The square root of 10 cubed. We're going to have to approximate that. The exact answer is 1/2 times 10 to the 3 halves plus 3. And we can't really simplify this at all. If we type this into a calculator, it should be about 17. Let's see if I made a mistake. The bonus content might be bad. 1/2 times 10 raised to the 3 halves, which is the same as 1.5, plus 3. Uh-oh. Uh-oh, what did I do? Oh, my parentheses are wrong. Whew. 17.311. There it is. I actually ran into that issue before, because what happens is when I'm doing this, I forget there's a 3. So what I have to do is I have to alt tab. But when I alt tab, notice what happened to the cursor. When I alt tab, it tabs me to the next part of the equation. So I have to be really careful when I'm typing things onto Desmos. All right, that's the end of the video. It's still only 8 minutes, but that's not a problem, right? You still have plenty of math from me. Again, I hope you didn't feel like you had to watch the rest of it, but maybe it was interesting. You got a cat. You got a little sneak peek of 6.6. Have a great day and let me know if you have questions.